Hi guys, today we are doing grade 12 maths paper 1 and we are looking at question 2 of the November 2025 paper, and we are given the infinite geometric series t plus 10, t minus 2 and t plus 4, and we are asked to show that t is equal to negative 2. Right, so what we know about a geometric series is we have a ratio, right, which is T2 over T1, which equals T3 over T2. And so we can get T minus 2 over T plus 10 is equal to T plus 4 over T minus 2. So we have this is our T1, our T2, and our T3. Now the student who sent me this and asked me to help out got 8 and negative 4 and 2. So hopefully those are the answers we do get once we are done with this. So we're going to cross multiply. So we're going to say T minus 2 times T minus 2. T minus 2 times T minus 2 is equal to T plus 4 multiplied by T plus 10, and so we get T squared minus 40 plus 4 is equal to T squared plus 14T plus 40. And once we get the T squareds to cancel, that's excellent. Take the let's bring everything across to make the t, so we get negative 4 minus 14 will be negative 18t once we come across, and that'll be 40 minus 4, which is 36, and so we get t is equals to 2. So that's correct. So let's just put therefore t is equal to negative 2, which is what we're supposed to get. Now they want the value of T25, and they want it in the form Tn to the b to the x. Okay, so what do we need to get? Well, we need to get our ratio, don't we? So we know that our ratio, so this was I'm just going to put here, so this was T2 working for T2.1.1, and just so we don't get confused, I'm going to do these working for T.1.2 in black, and because I don't want to run out of space. So we know that our ratio is T1 over T2, right? So our T2 over T1. And so that is T plus 10 over T minus 2. Sorry, T minus 2 over T plus 10. And now we know that T is negative 2. So it's negative 2 over negative 2 plus 10. And so we get negative 4 over 8, which is equal to negative 1/2. That's our ratio. And our first term, our a, is equal to t plus 10, which is negative 2. Well, we've already got it there. We know that it's 8. Plus 10, which is 8. Okay, so 8. So we know that this guy here was correct. 8 minus 4 and 2. So excellent. Looks like he got this question correct. Now they want T5, right? So now we've got everything that we need. So T25 is going to be our A, which is our 8, multiplied by our ratio, which is 1/2 to the power of n minus 1, right? So 8 minus 25 minus 1. Okay, I just want to, sorry, I should just note, we're using this formula from the back. Tn is equal to a r to the n minus 1. We've got our a, and we've got our r, which we got there. Okay, and so we get 8 times negative 1/2 to the 24. Now, the important part about this is that we have an even number, so this is going to be negative times a negative is a positive, right? So this is going to actually come out to 1/2 to the 24. So it'll be 8 times a half to the 24. Now I wouldn't go on, I wouldn't carry on doing this unless they didn't, see they wanted in t n is equal to b to the x. Now what's important about that is we have to get what b is. And so we need to simplify this a bit more. So we have the fact that it's 8. But now 8 we can write as 2 to the 3. So 8 we can write as 2 to the 3. Sorry, 2 to the 3, yeah. And a half we can write as 2 to the minus 24, right? Because if we, let's just cross that out. So 2 to the minus 24, right? So bring the 2 to the top and change it to minus 24 instead of plus 24. And then we have it all as 2's. And so we get 2 to the minus 21. And that's in the format that they ask. So T25 is equal to 2 to the minus 21. Now they want the sum of the infinite series. Okay. So we know that the sum of an infinite series is going to be sum to infinity is equal to a over 1 minus r, right? And so we get a, which was 8, and then our r was minus a half. So our r was minus a half, so it'll be minus a half. And so it'll be 8 plus a half, which is 3 over 2. So we get 8 over 3 over 2, which is equal to 8 times 2 over 3, which is 16 over 3. Okay. Let's look at this sigma notation. Now, a lot of yes, the students, they struggle with sigma notation because it's sometimes the last thing that gets taught. It doesn't really get taught enough in some schools, and so they don't know what it is. But what it means is that the sum of all the terms from k to 117, and they're telling us that p is equal to k. All right, so that's quite an interesting one because we've got p here. So let's just get the what the terms are, right? Because we can put T6 in by simply just subbing in 6 as our P. So T6 is equal to 4 times 6 minus 1. Now, I'm just going to just say, when you see the sigma notation and you see 4p, this is going to be arithmetic because the next one, T7, will be 4 times 7. So it'll just go up by 4 each time. If you have a to the power of p, something like that, then you know that it is a geometric sequence because it's going up, it's being multiplied. Okay, so that is going to be 23. Now our T14 is equal to 4 times 14 minus 1, which is 55. And the difference between that, T14 minus T6, is equal to 55 minus 20. That looks like a 5, but it's a 3, 23. And that's going to be 32. Now they want the value of k. Okay, so we're told that the sum of all these, so if I was to keep writing it from T1 all the way through to a certain number, k, then we would, what would the sum of that be? Okay, so I don't maybe need to do this, but I'm going to, let me get the first term and the second term. I probably don't need the second term, but I'm going to get it anyway, just to sort of show you guys. So T1 is equal to 4 times 1 minus 1, which is equal to 3. Okay. And T2 is going to be 4 times 2 minus 1, which is equal to 7. So that was just to show you 3, 7. You can see it's going up in force. Okay, but what I'm going to do is I'm going to use the formula, because if I find out the last term, that'll be how many times it goes up. So what I'm going to do is I'm going to use the sum of an arithmetic sequence, which is equal to n over 2, the number of terms, and then the first term, all right, T1, I'm just going to say plus Tn, right, the last term. Okay, so this could also be written as Sn over 2, sorry, S is equal to n over 2, and then it'll be first plus last. Okay, because I have the first, and if I have the last, I have the value of k, because k will be the last term. Because what happens is it just goes all the way up. So now what we actually need to know where it's we actually know the last term is 117, isn't it? So we can actually get the last term. So that'll be T117. So T117 is equal to 4 times 117, and then it's going to be minus 1, and that's going to give us 468 minus 1 is 467. You can check that on your calculator. Pretty sure it's right. If it's not, you guys are going to tell me in the comments, I'm sure. Okay, and so now we can get this, right? So we can say that n, so this whole sum, they tell us, is 26,675. That's the sum. Now the n is going to be 118 minus k over 2. Okay, because what it does is it starts at k. So we can just figure out that by saying 118 minus k. And then we're going to say it's going to be the first term. So now the first term is actually not, the first term is actually k, because it starts, so p is equal to k. So this down here tells us what is the first term. So in other words, if you had it starting at, it would sometimes say, I don't know, n is equal to 1. They could say p is equal to 1 and 117 here, but we actually don't know when it's starting, because it's starting at k. So p is equal to k. So we need to figure out where it starts. Okay, so the first term is actually k. So the first term is actually sub in for k, right? Was p. So if it said p equals 1, we would sub in 1. We actually want to find out t when we put in k, where it starts. So that's going to be 4, and instead of 1, I'm going to put here k. Sorry, so that's just misleading you guys a little bit there. Okay, so now we have the first term is actually the 4k minus 1, because it doesn't necessarily start at 1. And then we do know the last term is 467. Okay, now how do we get, why did we say n is equal to 118 minus k, not 117 minus k? Well, because when you look at a sequence, let's say that it was like we said p is equal to 1, and it goes up to 2, right? Well, how many terms are here? There's the term number 1 when you sub in. So let's just make P1. Let's just make this P. So the first term will be 1 because P, we start at 1. And then the second term will be P when we put in P is 2 because you add in integers or whole numbers from 1 all the way to 2. And so when you sub 2 in for P, you'll get 2. Now, how many terms are here? There's 2 terms. But now, if I put in 117, if I say n, to get n, if I say 2 minus 1, that'll only give us one term because 2 minus 1 is 1. So I have to say 118 minus k because there's 2 terms, right? So n would actually be 2 plus 1 minus 1, right? Because 2 plus 1 minus 1 would give us the 2 terms. Okay, I'm not sure if I'm fully clear on that, but it's 118 minus k because if I need to, there are 118, let's say k was 1, 118 minus 1 would give us 117, which is the number of terms if it started at 1 and went all the way up to 117. So that's why I used 118. Okay, and now I can just solve for k, can't I? So let's see. What's the quickest way of doing this? Well, I suppose we could times everything by 2. That would work. So yeah, so let's times everything by 2. So then we get 53350, don't we? I should really start using the calculator. I'm hoping you guys use your calculator in the exam because otherwise you're going to fall into a little bit of trouble, I think. And it's just not worth it, right? If I make a mistake, you guys will let me know in the comments and then we will have to just make an adjustment. Okay, so now this, it's all timesed in, right? It's all timesed in. So let's times it in. And so we get, I'm running out of space here. So what I'm going to do is I'm going to simplify it to what we should be. So I'm going to give you guys a challenge. And what I'm going to do is I'm going to say times this out. Okay, so times the 118 minus k in here yourselves and see if you get to the same answer. Okay, so we're going to get, just going to pause this video and work it out on a piece of paper, and then I will put in what you should get at the end, because this is simply just expanding out, so you should get this. Okay, so I get 0 equals 4k squared minus 6k minus 1638, which I can divide everything by 2, and I get 2k squared minus 3k minus 819. Okay, now I can actually put that into my calculator now. So you could use your quadratic formula, which I suggest you do, but I showed you in question 1. So you would put this into your quadratic formula and do it like I showed you in question 1. So question 1 of this paper, I already do one of these, so that should show you this. I want to save a bit of time here, and I want to now go mode, and I want to show you can actually just use your equation mode. So grab one of these silver or your white calculators. If not, you're just going to have to do the whole thing on a quadratic formula, and hopefully you guys are fine with that. And then we put a negative 819. Now we are hoping that we get at least one whole number and we don't. What's happening? Um, A is 2. -3, -3, and then 8, -819 is correct. Okay, there we go. X1 is equal to 21, and we know that it can't be x2 because our k cannot be negative. So therefore k is equal to 21. So let's annotate there. K is equal to 21. I'm pretty sure that's correct because we have a we have a whole number. So guys, if you want to do that by yourself and check my answers, this is I'm doing this the weekend of the paper coming out, so the memo is not out, and so I'm just getting answers, and we'll check when the memo comes out how accurate it is. I've seen some other videos and they're getting stuff wrong, so hopefully I'm not doing the same. So yeah, yeah, do this in the thing, and I'll see you next for next video for question 3. If this is helping you, if you're enjoying this, please like, subscribe, all that good stuff. If you haven't already, be doing loads more of these, and yeah, just helping you out in preparation. Thanks, and see you in the next one.